47, one of these blocks on a slope here. Lots of angles coming into this one then, aren't there? So we've got this 2 kilograms sprint coming down here, so 2g down, and it's an angle of 25. So this part here is 2 cos 25, and going down there is 2 sine 25. And I've already missed my g's out there, but I'll squeeze them in there. There's a normal reaction coming up here. It isn't exactly that though, because there's a force pulling it up here. This force is 20 newtons, and we're going to split that into its 2 parts as well. So coming up the slope, I've got 20 cos, that angle there's 15, and I've run out of room a little bit here, but I'll squeeze it in just to see the top there. That bit there is 20 sine 15. Just about read it. There's some friction stopping it being pulled up there. That friction I'm just going to put on as mu r. And it's actually that mu that we're going to have to try and find out. Lots to do. Got to find out what this normal reaction is first of all. So I'm going to look at the forces going away from the plane. So there's r there, and we've also got that one we just put on there, that 20 sine 15 is coming away from the plane. In the opposite direction, we've got that component of the weight there, so 2g cos 25. And that equals 0, because it's not coming off the plane or anything like that. So I can work out what r is. R is 2g cos 25 minus 20 sine 25, sine 15. I'm going to leave it like that. You can tap it in if you really want to, but we'll leave it like that. So now I'm going to look at the forces going up the plane, and that's being pulled by that force there, isn't it? So I've got 20 cos 15 going up the plane. Stopping it, I've got that component of the weight, so the 2g sine 25. And we've also got the mu r, so minus mu times, and there's what r is. So all of that in there, blah, 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 blah. And that's going to equal 0. It's going to equal 0 because it's moving at a constant speed of 8 meters per second. And so what is mu? So if I add all of that to that side there, it would leave me with 20 cos 15 minus 2g sine 25. And I need to divide by this bit here, which was the 2g cos 25 minus the 20 sine 15. And tapping all of that in gives me 0.877. And you think that's a lot of work? Well, it was 6 marks work, but we've still got quite a bit more work to do in part B. So for part B then, and we suppose we could go back up here to look at this. Part B, the force is now removed. So let's just get rid of all of that. There you go. All of that force is now removed. And so what's going to happen now is it's going to start sliding down the... Oh, it's certainly going to slow down, isn't it? So that means it's moving in that direction. So the friction is going to start... Just going to pause. Okay, just to clarify, yeah, the force is removed. It still continues moving up. So the friction is staying that way there. Sorry about that. It still continues to move. We want to find out when it stops moving up there. So let's look at the forces. Well, first of all, I need to find out what the new normal reaction is again, because it's changed. The normal reaction now is just the 2g cos 25. There's no force pulling up here anymore, so we've got a new normal reaction. That means we've got a new friction. The new friction was 0.877, that's not changed, times by 2g cos 25. And if we now look at the forces pulling, you've run out of space, forces pulling it up the plane, we've got nothing, have we? So we've just got this friction here, all of that friction there. And we've got the weight part of it, the 2g sine 25. And the force is equal to the mass times the acceleration. And the mass of this thing is 2, isn't it? And we want to know what the acceleration is. So I'm going to tap in all of that. And if I tap in all of that, I'm getting minus 23.86. If I divide that by 2, I'm finding that my acceleration is minus 11.93. I like it being minus because we want it to be not going as quickly up the slope. The question says, how far did it go? So S equals UT. No, not S equals UT plus half AT squared. No. No, U is 8 because it said it was constant speed of 8. When it stops moving, we're going to have a V of 0. I've got an A of minus 11.93 and I want to find S. So that's going to be a V squared equals U squared plus 2AS, isn't it? So look, just working that out as I've run out of room, I'm getting 2.68 meters.